For the given axial load and applied moment, this is the upward soil pressure distribution which the footing is going to experience. Now here this L is the length along longer span of the footing, B is the width of the footing, and here this D is denoting the thickness of the footing. Now to design the flexural reinforcement, we know the critical section is located at the face of the column. Let us see the cantilever length which has been placed along the length of the footing, and maximum moment is going to take place at the face of the column. Now this cantilever length, as you can see the load distribution, and the load distribution, what you can observe is uniformly varying. Okay, it is uniformly varying. So I hope you can compute the maximum moment at the face of the column or at this particular edge. Okay, so at this particular edge you can compute the moment. What you can do, you can consider a UDL and a triangular load and take the moment at the face of the column. Okay. Now this is going to give you maximum moment, and from that maximum moment you will be able to determine the reinforcement which will be placing along the length of the footing. Next, you can see I have taken the cantilever length along the width of the footing. You see the cantilever length is BC, and here you observe along the cantilever length you do not have any variation in the pressure. It is uniform. Only what is happening, this pressure is non-uniform along this dimension. So if you want to know what is the maximum moment, you compute what is the total load which is going to be experienced on this area. So you can compute what is the average pressure into this area. That will give you the total load, and this total load is going to act exactly at the CG of this area, exactly at the center, and you can compute the. I hope the schematic sketch is clear to you. Only thing is, you see the variation along the cantilever line. Here it is not, whereas here you have variation in the upward pressure along the cantilever line.